Hey guys, today we're going to be taking a look at different types of asymptotes in functions. So the first one we're going to look at is vertical asymptotes. Now you'll notice that I have filled out some of this because my first video did mess up halfway through, so that's all right. So first type of asymptote we've got is a vertical asymptote, which you should be familiar with at this point, but the actual definition is that if the value of f of x, your y value, can be made arbitrarily large by taking x's as close as possible to a, or as close as we need to get, as long as x is less than a, then x equals a is going to be a vertical asymptote. So you can see our examples here, and you can see we can get as big as we want by getting closer and closer. As x goes closer and closer towards a, our y value gets as big as we could possibly want. It'll just keep going up and up and up. And similarly, we can do it downwards if it's a decreasing one. So we get as close as we want to negative infinity just by getting closer and closer to a. Okay, but we'll never actually reach that value, obviously. Okay. So what's new about this is we can use this we can use these limit ideas to sort of look at this. And so our first one here, you can see the limit as x approaches a of f of x equals infinity. That's what you're going to have when you have an asymptote. It's either going to equal infinity or negative infinity. Now it is worth noting, you can see I've already put a star here. We'll circle the star, because that limit doesn't actually technically exist. Infinity is not actually a number, and so there is no actual limit. However, we do describe it this way often just because it's a good way to, or an easy way. We're doing it for convenience because it is an easy way to sort of explain what it looks like. We say it equals infinity. Well, it can never actually equal infinity, so it's not technically true, but it is a common way that we will describe it so that people will understand what it looks like. So we're going to look at rational functions here, which you have covered for the last couple years, but the idea here is for us to have a vertical asymptote. If we've got a function made up of a polynomial over another polynomial, it will have a vertical asymptote if at that value the bottom is equal to 0, but the top is not equal to 0. And it is important that the top not equal 0, because if they both equal 0, at that point, then you will have a whole, not an asymptote. Okay? So, if we look at this one here, x minus 2 over x squared minus 4, if we look at the top first, okay, the top tells us x minus 2 cannot equal 0, so x cannot equal 2. If we then look at the bottom, okay, then x squared minus 4 does equal 0, so x squared does equal 4, which means x would equal plus or minus 2. However, I already specified that x does not equal 2, so that is not true. X only equals negative 2, so we'd have a vertical asymptote at x equals negative 2. Okay? So we're going to look at this function here, a more complicated function, and we're going to do what we're trying to do is we're trying to describe, we want to know, is our function, basically what we want to know is it approaching infinity, or is it going down and approaching negative infinity as we go towards the asymptote from either side. Okay, so what you do is you're going to factor the whole thing. You got to factor it all up and find out where your asymptotes are. So our asymptotes are at negative 3 and positive 1, because as you can see, that would be a 0 for x plus 3 and a 0 for x minus 1. Now you'll notice that neither one of these conflict with the top, so we are A-okay, and we can just use those as our asymptotes. So what we're going to do is we're just going to look, we're going to make this, this chart here, which is very similar to one that you would have done in advanced functions. And we're just going to approach both of our asymptotes from each side. So there's our first one, there's our second one. Okay, and so what we're going to do is we're just going to look at whether each thing is positive or negative as we approach it from these sides. So if we go, as x approaches negative 3 from the left, it's going to be, so if we were slightly less than that, if it's negative 3.1, negative 3.2, or negative 3.01, negative 3.001. These are all negative numbers, so it's going to be a negative. If we approach it from the right, it's going to be negative as well, though, because it's still just negative 2.9, negative 2.99, whatever. Okay. However, when we do the 1, if we approach it from the left, if we're just underneath the 1, so we're at 0.9 or 0.99, 0.999, whatever. These are all positive answers. Okay. And if we approach it from the right, we're coming down from 0.1, 0.001, 0.0001, whatever. These are all positive numbers. Okay. Oh, it's worth noticing, I did gloss over this, but these are the 3 components of our function. So, yeah, so there you go. Anyway. Yeah, so now I did leave out that this should actually be a negative 1 right here. So actually, so I did actually make a mistake there, because that was a negative x, I'm just realizing, in which case we would take these 4 things and we would then just change the sign. So that one becomes positive, that one becomes positive, that one becomes negative, that one becomes a negative. So sorry about that, little mistake. Anyway, if we move on to x plus 3, if we approach x plus 3 from the left, so we use negative 3.01, negative 3.001, whatever, as we're approaching from that side, and we add 3 to those values, we're going to have negative numbers there, okay? It's going to give us a negative number. However, if we approach it from the right, so we're a little bigger than negative 3, then we're going to be in the positives, okay? And then if you use a 1, regardless of which side you approach it from, because you're adding 3, it's always going to be just positive in both cases. Okay. When we do the x minus 1, we approach the negative 3. So whether it's a little bit bigger than negative 3, a little bit smaller than negative 3, those are both going to give us negative numbers. If, however, we do it with the 1, when we approach from the left, a little bit smaller than 1 is going to give us a negative number. So if we had 0.9 minus 1, that's going to give us a negative number. If we approach it from the right, so it's a little bit bigger than 1, and then we subtract 1, it's going to give us a positive. Okay, so overall we can look and we can say the whole function then, if we look at the whole function, if we had a positive divided or times a negative, it's actually divided by a negative and a negative. It doesn't make a difference though, it's going to give us a positive. Okay, if I have a positive and a negative, it'll be a negative. 2 negatives and a positive will give us a positive. And 1 negative, 2 positives will give us a negative. Okay, and so what this tells us is that what the function is approaching is going to be positive infinity, negative infinity, positive infinity, and negative infinity. Okay. So, if I were to graph this, okay, if I were to graph this and I've got my number or my asymptotes at negative 3 and positive 1, okay, so that would be the negative 3, and then I do it again at positive 1. Positive 1. So what that means is as we approach the negative 3 from the left, it's going to be going up like that. We don't know where it's coming from or anything, but at this point that doesn't matter. As we approach it from the right, we'll be going down to negative infinity, and here it'll be going up to positive infinity, and here it'll be going down to negative infinity. Okay, and beyond that we don't know what it's doing. Over here it could go way up or it could go off to the side. I don't know, it doesn't matter. In between here we have no idea, but that's okay too. That's not what we're looking at yet. We'll get there. Okay. So that's it for vertical asymptotes. So I'm going to pause and I'm going to split this up into multiple videos so you can now move on to video number 2.